Welcome to the online platform of KTCD College of Arts and Science. I am RESHMISREE, HoD Department of Mathematics. In this video, we discuss about the equality of two real numbers. It will be proved by the following theorem. The theorem states that two real numbers a and b are equal if and only if for every epsilon greater than 0 it follows that modulus of a minus b less than epsilon. So we have to prove a equal to b for every epsilon greater than 0 it follows that modulus of a minus b less than epsilon. So here are given a equal to b if and only if modulus of a minus b less than epsilon. So epsilon will be greater than 0. We know that two numbers are equal if 2 is equal to 2, then 2 equal to 2. If we take a equal to 2, b equal to 2, then this will be equal only if two numbers are equal. But in real analysis, we prove that two numbers are equal if and only if a minus b, the distance between two real numbers, must be less than epsilon for epsilon greater than 0. So here is the problem to choose epsilon. What will be epsilon? Sometimes epsilon will be 0.0000 into 10 raised to minus lakh. Okay, 1 by 10 raised to minus lakh 0.0000 etc. That will be the epsilon. Epsilon will be a minute quantity which is closely related to 0. So how will we prove this theorem? In this theorem, we have two phrases. What are the phrases? One is for every epsilon greater than 0. One is for every. And the second one is if and only if. So, to prove if and only if in mathematics, we have proved that theorem is true in two directions. Okay, that is, first we assume that a equal to b. Then we prove that modulus of a minus b less than epsilon. That is one direction. Next direction is the converse of the above statement. That is, next we assume that modulus of a minus b less than epsilon, and we will prove that a equal to b. So, to prove if and only if in mathematics, we have to prove theorem in two directions. First is assume that a equal to b, then prove that modulus of a minus b less than epsilon. Next one is assume that modulus of a minus b less than epsilon, then prove that a equal to b. Okay. So we will prove the first condition. So we are assuming that a equal to b and prove that modulus of a minus b less than epsilon. Okay, suppose that a equal to b. Then what will be the modulus of a minus b? Modulus of a minus b equal to modulus of a minus a. Substitute b equal to a in this equation. We get 0. This follows that modulus of a minus b equal to 0, but we can write than 0 as epsilon, that is less than epsilon, because no matter what epsilon greater than is chosen, we say a number is less than epsilon, we simply mean that the number vanishes or is 0. That is the reason. We say a number less than epsilon. Here we are proving that a minus b equal to 0. So that will be written as mod a minus b is less than epsilon. In this statement, we are given that a number less than epsilon simply means that a number vanishes. The number vanishes. That is epsilon vanishes, or it is equal to 0. So the first case we will prove. Suppose that a equal to b, then we will prove, and when prove that modulus of a minus b less than epsilon. Now the second part is we assume that modulus of a minus b less than epsilon. Then we will prove that a equal to b. To prove this, we assume a contradiction. We give a proof by contradiction. We have to prove that a equal to b. Okay, we assume that a not equal to b. To prove a equal to b, we assume that a not equal to b. And in the statement, we are given that for every epsilon greater than 0, we have modulus of a minus b less than epsilon. That is, we have to prove that for every epsilon greater than 0, by assuming modulus of a minus b less than epsilon, we have to prove that a equal to b. For that, we first assume that a not equal to b, and given the statement that for every epsilon greater than 0, we have modulus of a minus b less than epsilon. So, since a not equal to b, there exists a difference. We know that modulus of a minus b equal to epsilon naught. If we take a equal to 10, b equal to 5, then the difference must be 5. Here a not equal to 0, not equal to b means modulus of a minus b is a constant number. We take that as epsilon naught. Okay, then epsilon naught distance must be greater than 0. So epsilon naught greater than 0. So we have modulus of a minus b greater than 0. But our assumption is that modulus of a minus b is less than epsilon. These two reasons are not possible. We assume that a not equal to b, and we prove that modulus of a minus b greater than 0. And here we assume from the statement that modulus of a minus b less than epsilon is true. Modulus of a minus b is less than is true for every epsilon greater than 0. So this must certainly be true for particular this epsilon naught. However, the statements modulus of a minus b less than epsilon naught and modulus of a minus b equal to epsilon naught cannot both be true. So this is a contradiction to your assumption that a not equal to b. Hence, a not equal to b is unacceptable. Therefore, a equal to b. Hence the proof. So, we have proved that two real numbers a and b are equal if and only for every epsilon greater than 0, it follows that modulus of a minus b less than epsilon. Okay, thank you.